I'm Benny Bauer. I'm from Israel. Right now, I'm an independent cloud architecture and serverless consultant. Before that, I used to work at Autodesk. I was the cloud architecture for AutoCAD, which is the leading design or computer-aided design application. And we've built mobile and web applications of AutoCAD and dealt with many interesting cloud challenges and made it possible with the most cost-effective service in Autodesk, which leads me to serverless. So before I start, I want to get some vibe from you. How many of you heard about the term serverless? Just raise your hands. Okay, most of you. How many are already using serverless for anything? Just a few, all right. How many are you using AWS, Google Cloud, Azure, Bluemix, any other public provider? Okay, private cloud, anyone? All right, okay. So to understand what is serverless, we need to get some context. And the context is the evolution of the cloud development or the cloud computing. And I see that most of us here are pretty young. So once upon a time, when someone wanted to deploy his servers or his application, he had to own his own server and install it and deal with network and with everything. And this was the on-premise area. Later, there already been data centers, and it was possible to host a physical place or a server inside a data center. Then came the virtualization, and we didn't need to deal with physical bare metal servers. We could use virtual machines. And later on, infrastructure as a service, which is AWS, Google Cloud, Azure, all of the big guys, started providing this infrastructure simply as a service, and you could have spin instances pretty easily. And this evolution started from building your own thing and evolved to be able just to use it as a commodity. I want to spin an instance. I can just click in a console and pay by the hour. So this was the evolution until infrastructure as a service. And it all was an evolution of compute. But then another layer came up, and it was the platform. So with platform as a service, if you heard about Heroku or Google App Engine or Elastic Beanstalk by AWS or many others, you didn't have to deal with the server. You just could deploy a package of your application, define auto-scaling, and again, pay by the hour. It made it easily. Right now, we're in the era of serverless. And serverless basically means that you can develop your application without maintaining or managing your backend, your physical server or virtual server. So what is serverless? There's this term of serverless has been overused for many meanings, and I'll try to make some order here. The first one, I'm going from the right to the left. The first one, as I call it, B2D, business to developer SaaS, software as a service, is a bunch of managed services provided by companies that implement specific functionality that you probably need for your application. For example, Auth0, they implement the whole authentication process for you. So I don't need to implement it myself. I can use Auth0. Twilio provide you with a managed service for sending SMS. Algolia do the same thing for search. I don't need to implement search. I can use Algolia. And there are a bunch of other managed services that I can use. Every cloud provider also has their own managed services. S3 by AWS, which is the file hosting, is a managed service. I don't need to deal with the file server. I can just use the service itself. So this is one meaning for serverless. Another meaning is backend as a service. So most 90% of the simple applications, or 90% of the mobile applications are pretty simple. You have something that the mobile app does, and it needs also authentication. It needs maybe push notifications, maybe some analytics. That's the only thing that you need from the backend. And there are services like Firebase, like AWS Mobile Hub. There was Parse by Facebook that was acquired by Facebook, that they provided you with those functionalities for the backend. So authentication, push notifications, analytics, a simple database that you could use, and you just could pay for the service, and you didn't need to implement your own backend. But sometimes you need to implement your business logic on the backend. And for this, there's a FAS, or function as a service, and this is the latest buzz that there is in serverless. And a function as a service is a set of platforms or services that enable you package your code, deploy it, and pay for the usage of this. And all the cloud providers have this such service. So AWS has Lambda, which is the most mature. And the most, when I say it's the most mature, it's out there only for about 3 years, less than 3 years, but that's the most mature and has plenty of functionality. Azure has Azure Functions, Google has Google Cloud Functions. There is OpenWhisk, which is implemented by IBM and open source, and we'll talk about it a bit later. So this is FAS, function as a service, and this presentation is going to talk about function as a service. Because for me, this is the real big thing that we have in serverless. There's another term, there's another meaning for serverless. There's a framework called Serverless Framework, which we'll also see, maybe we'll see a demo of it. Okay, so what is function as a service? So it's as I said, it's a fully managed compute. It means that I don't need to own a server. I don't need to spin a server. I don't need to provision, keep it patched with all the security updates. I don't need to define scaling on it. And I get monitoring and logging out of the box. So it means that there's less operations for me to deal with. And I say less, it doesn't mean that there are no operations at all. Then I deploy my code and package, upload it through console or through CLI. And this call, when this call will be triggered and executed, I will pay only by the execution time, which is per hundreds of milliseconds, which is a big game changer in the industry of the cloud, because it means, basically it means that I have no more idle instances running in the cloud. Everything is fully utilized. So how it works. As I said, you deploy your code, and then you need to define triggers that will run this code. And the triggers could be HTTP request. It could be integration with other services. For example, if I'm on AWS and I have an AWS Lambda function, I can define that when someone uploads a file to S3, which is the storage service of AWS, it will trigger my function. And I can do it the same with their database service. If something changes in the database, I can trigger function. I can define scheduled tasks. I can trigger functions due to messaging through the messaging services, and many, many other integrations that can trigger my function. And those integrations just continuously, there are more and more types of such integrations. And the meaning of this is that the architecture of my application becomes much more event-driven. And we might talk about it soon. Another thing is, after I deployed my code, I define the triggers. Now, when the code will be triggered as a result of one of those events, my code will be executed. And if this event happened millions of times concurrently, it will auto-scale automatically. There are some limits, but theoretically, it can scale automatically without me defining anything on it. It also means that besides the auto-scaling, it means that I'm highly available. I don't need to do anything special to be highly available. I don't need to maintain 2 instances in 2 different data centers to be highly available for an endpoint or for a function. So it also means that when my applications are translated to or transformed to functions, to a set of functions, and with event-driven architecture, it also means that my architecture becomes much more distributed. And there are good sides to it, and there are bad sides to it. The good sides are that availability, fault tolerance, scaling, it's something that can be achieved much easily. Even distributing work between different teams in organization can be easier when every team owns a function or a set of functions. These are all things that are benefits of microservices, but they get to on steroids with serverless or function as a service architecture. The bad sides are when you have a distributed architecture, you deal with many issues like network overhead, like being able to trace the flows in your architecture, to trace the to monitor your application and to debug it. It becomes more difficult. So right now we have these 2 building blocks. We have the function, and we have a set of services that can trigger events to trigger those functions. So let's start and build some useful cases for it. So one example is there is basically you can easily build a web backend, and a good example of it is a Cloud Guru. A Cloud Guru is a tutorials website for AWS. They built the whole their whole application totally serverless. They don't spin any servers, and they use all of the meanings of serverless. So they use Auth0 for authentication. They use Firebase as the backend as a service, and they also use Lambdas for specific, their unique business logic that they need to execute. And the way this architecture looks is, again, no servers. We're only using services. And this example is how would I build it with AWS. So I can use S3 to host my static files. I can use an API gateway to map endpoints to functions to be executed. The functions are running on Lambda. And I can use a database, whether it's a DynamoDB in AWS as their managed database, and all of this without maintaining a server myself. And here I got a web backend. I can do the same thing with mobile backend. Okay, same thing. I have my mobile app. It makes requests to an API gateway. The endpoints are mapped to Lambda functions. Lambda functions can read from database, write to the database, and respond back to the app. Another useful use case is file processing. Actually, this was the first use case when AWS Lambda was released. It was the only event that you could use was events on S3. So when a file was uploaded, you could trigger an AWS Lambda. And this is useful when you want, for example, to make some processing on the file. So you have an image that you're uploading to your storage, or the user has uploaded to a storage. Once this image has been uploaded, you can spin a Lambda that will transform this image, or change its size, or whatever. And the nice thing about it is that you can use this event to trigger several different functions. So for example, I want to generate a thumbnail, and I also want to resize the image. So there's no limit to how many events I can trigger, or how many functions can react to an event. Another popular example is bots. Probably all of you heard about Slack. You can build your own commands in Slack, or your own bots. So when you shoot a command from Slack, you need some quick processing and return a response. So this is also a very useful use case that you can do same way with API gateway and with the Lambda behind it, and without spinning any instances. Another popular use case is stream processing. So there are managed services like Kafka that do the same thing as Kafka. So Amazon has Kinesis. So when you have real-time data coming up, real-time events coming up to your application, whether it clicks of the users or any analytics that you want to do, or logs, and you need to process them. So you can also define events that when this data is coming up to you, you can crunch it with the functions, and then put in your storage, in your database, whatever you want. As I mentioned, you can also define schedule tasks. So it's another use case that I want to have like a daily job, or to run a daily build on my code, or whatever. Usually, when you need to build a scheduled task, you will want to make sure it's available. So you will need to have a few instances, just for the case that if one instance has failed, that another one will run the job. But then you need to deal with coordination between those instances. So there are quite a few problems. And again, this is something that you get out of the box with using functions that react to schedule tasks, to schedule events. Another use case is operations. There's a nice open source developed by Capital One tech teams called Cloud Custodian. They're using events and Lambdas to enforce policies on their AWS resources. So they're using the events of CloudWatch, which is the monitoring of AWS, or a scheduled task to enforce that there are no idle instances, or no one has spinned an instance without tagging it correctly. So it's another use case that maybe you didn't think about. Another nice example is using function as a service for CI. So there's an open source called LAMP CI. What they basically do, they using GitHub triggers, GitHub webhooks to trigger Lambdas, which will clone your repo. They will build it, and they will store the artifact of this build in S3. So this is another nice example of implementing CI without owning an instance. Obviously, another useful use case is IoT backend. So in the Internet of Things, you have many sensors that send many data, and usually what you need is just do some small processing on the data that you got from the sensor, and you need it scalable, and so this is, again, something that function as a service can be useful at. So there are a bunch of other use cases, and I'm not mentioning them all because I'm limited in time. But there are also limitations, and it's important that you will be aware of the limitations, because nothing is a silver bullet, and you cannot do everything, or you will not want to do everything with function as a service. And I believe that the future is hybrid, and you will have some of the things will run on your own servers, and some of the things will run as serverless. So the first thing is stateless. There's no state on the functions, meaning when you call a function and then you call it again, you might not get to the same instance that was triggered last time. So you should not store anything in the memory, or you should not count that there will be something in the memory or at the disk space of this function. So this is something that is very important. It also means that you cannot implement sticky sessions with with a function as a service, because the functions are running on containers, and these containers are ephemeral. So maybe next time you will get to a different container, or when you have many requests coming up and triggering many functions, those functions will spin on new containers. So never keep the state on the instance itself. It means that you should either pass the state on the request, or you should use cache or database for storing the state if you need it. And again, this is by design. This is not a bug. This is the way that functions as a service are implemented to be able to scale and to be able to utilize it better. Other limitations are just defined by the provider. So all of the all of the FUS providers, whether it's AWS, Azure, Google Cloud, IBM, they have limits for the execution time of the function. So the limit is usually 5 minutes. Your function cannot run more than 5 minutes. There's a limit to the memory that you can consume on this instance, the disk space, and the package of your code that you can upload. So again, you should be aware of that. You should check whether your use case is good with that. Another thing is latency. So as I mentioned, the functions are running on spinned containers, and these containers are ephemeral. So the first time I will call a function, it may take up to 1 or 2 seconds for the container to load and run the function. So, or if you didn't call the function for a while, I think it shows like 5 minutes that a function wasn't called, wasn't triggered, then this container, either will be disposed, or it will be posed, and it will take. It can take, again, up to 2 seconds for it to get warm again. And this can also be inconsistent. AWS, for example, they don't show how they implemented the AWS Lambda. So even if you have a container that is being called with many requests, they could just decide that they change this container, and you might get one request out of thousands or hundreds of thousands that will be a bit more late. Okay, but usually the responses can take up to 200 milliseconds, or it's pretty quick. But again, if latency is very crucial and you cannot live with 2 seconds latency once in a while, then you should be aware of that. Costs. I'll get to the bottom line. You pay in AWS Lambda, you pay per 100 milliseconds. For EC2, which are the instances that you spin, you pay by the hour, okay? But the bottom line is that if you have a low scale, a low load, or a spikes once in a while, you better use Lambda. But if you have a heavy load, it might be beneficial or cost effective to use EC2. So again, something that you need to be aware of. And of course, there's the vendor lock-in. The vendor lock-in is not because of the function itself, because the function is just a piece of code. The vendor lock-in is in the events, in the triggers, and all the integrations that you do with the other services by the same provider. So you should be aware of that as well. And it's a question of trade-off, whether you want to have convenience where everything is implemented for you and you don't need to manage anything, or you need control and then you probably will do the things yourself. So for the vendor lock-in, there are alternatives. There are open sources that implement a layer of function as a service. So there's the OpenWhisk project. It was developed by IBM and now it's in the Apache incubator, which allows you to run function as a service on any data center that you want, on any infrastructure that you want. There are also ARM functions. Again, you can run your functions on Dockers anywhere you want. For Mesosphere, there's the Gestalt framework that allows you to run serverless on Mesosphere. And for Kubernetes, there are those free open sources on the right, which implement function as a server on top of Kubernetes. Besides that, there are other challenges. As I said before, when working with a serverless architecture, your application becomes very granular, and there are downsides to it that I mentioned before that. And development becomes a bit more rough, because when you're integrated with other managed services, it's hard to mock them, or it's hard to run them locally. There are a few solutions for part of the things, but you should be aware of that. Okay, so these are all where the limitations and the challenges, and there are a few frameworks to help with some of the challenges that we have, especially for the development and managing and deployment of functions. These are the major ones. I think part of them are working with only specific cloud providers. Serverless framework, which is the most mature one, works with most of the cloud providers. And there's also tooling for those things that are missing, like having a better metrics monitoring on the functions, or having a security layer for the functions. There are some tools and services that are integrated, and I believe we'll see more and more tools in the years ahead. Okay, so let's make a short demo of building a simple backend with an API gateway and a function behind it. I'm going to use the serverless framework for this. Serverless framework, it's very easy to install. npm install serverless, and you got the framework. And then you can create a new project. As I mentioned, the serverless framework supports various providers, and it supports also various runtimes on those providers. So, for example, on AWS, you can run Python 2 and now also Python 3. You can run Node.js, you can run Java, and you can run C#. So I'm going to create a project on AWS with Python. So I need to provide the template that I want to create. I want to create AWS Python. Oh, sure. Is it better? OK. So I'm going to create a project with a template of AWS Python. And what we've got here, we got 2 files. We got the handler py, and we got the serverless YAML. The handler py is the function that I'm going to execute. And I got like a sample here. The sample, I wanted to return hello, hello world. Status code will be 200, and that's about it. And the serverless YAML is the configuration of the function, which events are going to trigger the function, where it will be deployed. These are the things that I can configure here. I want to deploy it to EU Central region. And here I want to define what will be the triggers that will run this function. So the event that I want to do is an HTTP event. I want that the path hello, when it's called with a GET request, will trigger the function hello, which is in the handler file. Okay, this one. So I got it configured, and now I'm going to deploy it. So this can take a few minutes, because what it does behind the scenes, it creates a CloudFormation file, which is a CloudFormation is a way for AWS to define the resources that you want and to build them. And it creates an S3 bucket to upload the code to it, to deploy the code to it. And it also will create the API gateway with the paths that I defined, and it will deploy the function itself. And it will also manage the permissions between the API gateway and the Lambda function, so that it can, and the S3 bucket, so that they can access each other, so that the flow can work. If I wouldn't have using the framework, I had to do it myself, whether with the AWS CLI or with the AWS console, and it would have been much more complex. Here you can see that with 2 lines of the framework, I can create the project and deploy it. So while it's running, I want to show you other things that you can define in the serverless YAML. So as I said, there are other events as well. If I want to define that this function will be triggered as a result of uploading a file to the S3 bucket, I can do it here. Just specify the bucket that should trigger. I can create a scheduled task. I can configure which messaging topic will trigger the function, and many other stuff. I also can create my own custom resources. Let's say I want to create another bucket to be able to deploy the static pages that I want to have in my application. I can do it through here. So it's pretty nice. OK, so it finished the execution. What I got back is an endpoint for my request. So let's go. Without get. OK. And here I got my message. So let's say I want it to be a bit more intelligent. I want to pass a parameter with the name that I want to say hello to. So I'm going here, And the path and the definition of the event and the path, I'll provide the parameter name that I expect to get. And here I need to take it. I need to take this payload and put it in the code. So if you see here, we have the event argument, and the event argument has all the different input and the different parameters of the event that was triggered. So I can go and just get out of this event. I can get the path parameters and name. Sorry. And now I'm going to deploy it again. I need to deploy everything. I could have deployed only the function if I changed only the function code, but because I changed also the API gateway definition, I need to deploy everything. So it will take only the delta. It will identify that I need to change the API gateway. It will update only the API gateway. This, again, can take a minute, maybe. And maybe in the meantime, another thing that I can do is specify in the serverless YAML any environment variables that I may want to use in the code. So I can define them here. I can use variables in the YAML itself and configure them from outside as well if I want to change them. OK, so it's ready. So let's say hello Krakow. And now I got it. But maybe I need to write Krakow with C. I'm not sure yet. So anyway, we got it here. And if I want to change only the function itself, so let's say I want to add an exclamation mark at the end. I don't need to deploy everything. I can deploy only the function itself, which will be much more quicker. And it's ready. All right. So this was a very simple demo of how to create functions and how you can use the serverless framework to create it easily. And another interesting thing about the serverless framework is that it's pluggable, and you can build plugins to add more functionality to the framework, and it's pretty nice. OK, so I got to run. I have only 6 minutes left, so we do it quickly. This function as a service also introduces new patterns for development and for architecture, and at all to the business of writing cloud applications. And there's a definition termed by Simon Worley about worth-based development. With functions, you can know the exact cost of the function because it depends on the time it runs and the number of times it was requested. And you can now look at your application and analyze how much do you need to charge from your users based on how much it really costs you. Because again, it's 100% utilized, so you can have a better estimation of what will it cost. And it's also good for developers when you need a case of, I have a technical debt, I have a function that I need to optimize. You can just come and show that if you make this function twice faster, it will reduce the cost almost by half. So it's a good use case. It's a good case to tell to your bosses. There's another thing that AWS published in last November, which is They have the AWS Marketplace, which was that you could install different applications on your servers, but now they also expanded it to you can use services, software as a service, without installing anything for your applications. And this means that anyone can write a Lambda function, put it on the marketplace, and get money for it, right? So it's like an app store of services. And I think this small thing that they published is going to, it can make a big difference in the whole ecosystem of SaaS at all. Architecture, and already mentioned, the architecture becomes much more distributed, much more event-driven, and it's interesting to think what is the role of frameworks like Rails and Django in a world of functions when you don't have the whole MVC layers in your applications. So it's interesting. I think we will see more and more frameworks like the serverless framework than a full-blown frameworks that we have today. And for operation, DevOps is changing. So it will be less about provisioning instances and patching them. It will be more about how do I manage this scale of functions? How do I monitor them? How do I make my architecture more cost-effective? To sum it up, I'll try to predict the future. I think the costs will get lower and lower for these platforms. We'll see less limitations that are currently enforced by the providers. We'll see more and more use cases, and tooling, as I said before, is going to explode in this area, in this domain. And if there's a takeaway that you can take from it, this is my formula for ROI, for return over investment. You always want to make your value higher, but there are costs that you're paying, and you want to reduce them. So you cannot. I'm not talking about reducing the cost of the people, but you can reduce the cost of operations and the time to market using serverless. And so I believe we're in the right direction here. So consider the limitations that I mentioned, and be aware of the new emerging practices and where we are going with the cloud. I really think, as I said, the future will be hybrid of many serverless functions or architectures aligned with your special use cases that you still need to run on your own servers. Dziękuję. Thank you.